Sam.
Hi, I'm Megan.
Hi, I'm Tess.
Hi, I'm Haley.
And we're the AU Squad.
And today we'll be teaching you about linear motion, relative motion, and kinematics. On to the history.
Okay.
So on today's history lesson, we'll discuss linear motion. Some of the key points of it are Newton's first law. It derived from Newton's first law of motion, which is an object in motion stays in motion unless an external force is acted upon it. And the people who pretty much discovered it is Galileo, Newton, obviously, Borelli, and Rudolf Steiner.
What I just demonstrated was linear motion. Linear motion is a one-dimensional motion along a straight line. Now on to the math.
Hi, my name is Megan Anthony, and I'm going to explain the math of the SAM portion, which you just watched. The delta x represents distance. The half is just a variable that includes the equation. The vix is your initial velocity, the fx is final velocity, and the t represents time. I filled in 14.63 for the distance for delta x because I know that 576 inches is 14.63 meters. Left the half. 0 is her initial velocity because she's not going anywhere, so it's 0. Plus the VFX, which I'm still looking for, times the time, which is 9.85 seconds. I divided by the 9.85, so I could just have half VFX. I times by 2, divided by a half, but I hate dividing by fractions, which gives me 2.98 meters per second is her final velocity. Woo!
They first discovered relative motion with the sun observed in a laboratory. They also used the Galilean transformation, also known as a model or a figure. It was discovered by Galileo and Johannes Kepler that did the sun observation.
Welcome to Kings. Due to meet people, we have to film this here. So relative motion is the motion of another object in relation to another moving object. I think that's what it was.
Alright, so I am doing the math behind Tess's jump. So we're going to find the velocity which hits the ground. So we are going to use this equation, which the Vfy squared stands for final velocity, the Viy squared stands for initial velocity, 2 is just a variable that's already in the equation, g, which stands for gravity, and delta y, which stands for the height in which she was at. We already have what we found, and we're just trying to find the Vfy. We have the Vfy squared equals the initial velocity, which is 0, plus the 2, which is already in the equation, gravity, which is negative 9.8, and the height, which is negative 1.9812 meters, and it's negative because she's descending. So, we times the 2 times the gravity times the delta y, have Vfy squared equals 38.83. So now we're going to square root both sides, and we're going to end up with the final velocity being 6.23. Thanks for spending time with the AU squad, and I hope you learned something today.
And next time when you're walking down the street or jumping in a pool, I hope you think about relative motion and linear motion. Have a good day.
Bye!
Bye.